Hi, welcome to the TigerGraph's embedding tutorial. In this session, we'll explore how TigerGraph's native vector support enables powerful hybrid graph and vector searches. By combining the strengths of graph databases and vector databases, TigerGraph allows you to perform advanced analytics on both structured and unstructured data. We'll walk through setting up a financial graph schema, loading data, installing vector search functions, and performing various types of vector searches. Before we begin, make sure you have the following prerequisites. If you don't have TigerGraph installed yet, please follow other tutorials to set up your TigerGraph environment. You can follow along using the GSQL shell in a web browser at localhost on port 14240/GSQL. Alternatively, you can use GSQL on the command line. We will use GSQL shell for this tutorial. You can also find all the queries we used in this tutorial at the link in the description. First, we'll define the schema for our financial graph. This includes creating vertex types like account, phone, and city, as well as edge types like transfer and has phone. We'll also add vector attributes to the account and phone vertices to store their embeddings. To do this, we'll run a GSQL script that creates the schema and adds the vector attributes. Let's execute the script now. The schema is now set up. We've created a graph called Financial Graph with vector-enabled vertices. This allows us to store and search embeddings directly within the graph. Next, we'll load data into the graph. We can load data from an S3 bucket or local files. For this demo, we'll load from the local tutorial files. The loading job that maps the data files to the graph schema, including loading the vector embeddings for the account and phone vertices. Embeddings are numerical representations that encapsulate information about entities, such as their behavioral patterns, relationships, or attributes. In TigerGraph, embeddings enable hybrid searches by combining structured graph data with unstructured vector data. The data is now loaded. We've successfully populated the graph with accounts, phones, and their corresponding embeddings. Loading vector data automatically builds and updates a similarity search index to speed up searches. To perform vector searches, we need to install the Graph Data Science package. The package provides the functions and tools for vector operations, such as calculating distances and performing nearest neighbor searches. You can also see these built-in function implementations by using command show function followed by the function name. Now comes the exciting part, performing vector searches. We'll start with a simple top K search to find the most similar vectors to a given query vector. Let's run a query that searches for the top 5 most similar account vertices based on their embeddings. The results show the top 5 accounts with the most similar embeddings to the query vector. This is a basic example of how vector search works in TigerGraph. Next, we'll combine graph pattern matching with vector search to make a hybrid search. This allows us to filter the results based on specific criteria before performing the vector search. For example, let's find the top 2 most similar account vertices from a filtered set of accounts. The results show the top 2 accounts from the filtered set. This demonstrates how we can combine structured graph queries with vector searches for more targeted results. Now, let's take it a step further and perform a vector search on vertices matched by a graph pattern. This allows us to find similar vectors within a specific context. For example, let's find the top 2 most similar account vertices that are connected to a specific account through a series of transfers. The results show the top 2 accounts that match the graph pattern and have the most similar embeddings. This is a powerful way to combine graph and vector searches for advanced analytics. Finally, let's integrate TigerGraph with Python using the TigerGraph library. This allows us to run queries and perform vector searches programmatically. We'll connect to the TigerGraph instance and run a vector search query from Python. The Python script successfully executed the query and returned the results. This demonstrates how you can integrate TigerGraph's vector search capabilities into your Python workflows. To maximize your experience with TigerGraph, I encourage you to explore other available tutorials. Thank you.